You may have seen the video I produced last year showing how much fun and how easy it is to do EAA with an 8-inch Schmidt Cassegrain on an Alt-Az mount. Well, I'm back here at Lake San Antonio once again. This time I want to show what you can do in EAA with a wide field refractor. Now, why would you want to have a wide field refractor? Well, there are a lot of big objects out there, like the Andromeda Galaxy, the Triangulum Galaxy. There's galaxy clusters, like the Virgo cluster. And there are fairly large nebula, like the Orion Nebula, the Heart Nebula, and the Veil Nebula, that you really can't do justice with something of a longer focal length. And this scope here that I have is a 360 millimeter scope, so it will give me a very wide field, and I can capture those objects in that one field of view. And we'll do a demonstration on that a little bit later when it gets dark. So the scope I'm using tonight is SharpStar 61 millimeter EDPH, and it's their 3 version. It's a 61 millimeter aperture. It is a focal ratio of f5.9, and as I said before, 360 millimeters. It's a triplet, and it uses 2 extra low dispersion glass elements in there. I also have their field flattener in here, so that I have a flat field out to 44 millimeters. So this scope cost $549, and the flattener $199. Now, this is not really a review of the SharpStar, because there are quite a few other wide field refractors in the $450 to $600 price range that you might consider. And I looked at a number of them, such as the Skywatcher 62 millimeter doublet, the Apertura 60 millimeter doublet, and the William Optics 61 millimeter doublet. And these are all anywhere from f5.9 to f6.5, so they give you a wide field as well. So I'm going to put links to all of the equipment I discuss in this video down below in case you're interested to get more information about any of those. Now, I've paired this scope with an ASI585MC Color Pro camera, which is a cooled camera, but you really don't need cooling for EAA. I just bought the cooled version because I also do traditional astrophotography, and I was willing to pay the extra $200. So this is $799. But you can get the uncooled version, which will work just fine for EAA for $599. What I like about this particular camera is it has a fairly large diagonal at 15.9 millimeters, which is important for finding objects in the night sky. It's got a nice deep well, and it has the 0 amp glow. Now, if you're on a tight budget, I think the ASI585 is also a good choice because its 12.9 millimeter diagonal is still large enough, and that one sells for $399. And again, this is not a review of any ASI cameras. It's just I want to explain what camera I chose and why I chose it. And lastly, in keeping with relatively low cost and simplicity, I'm on an Alt-Az mount, which I borrowed from my friend Dave, who's next door. And this is a Skywatcher AZ GTi Alt-Az mount. Now let's talk about how I'm going to power the mount and the cooler on the camera. Actually, I'm probably not going to use the cooler tonight because, as I said, in EAA you don't necessarily need a cooled camera. But in order for the camera to work, you do have to have the cooler power hooked up to it. I'll just set it so that it's 0 power. So I'm going to use this power bank from Talent Cell. And this is the only power bank from Talent Cell that I would recommend because it uses 4 lithium iron phosphate cells in series to give you 12.8 volts. And that's a true 12 volt power supply. So this is a 6 amp hour version, which will run for many hours doing EAA with a lightweight setup like this. Now, there are other power banks from Talent Cell and others that use 3 lithium nickel manganese cobalt oxide cells, and you'll see in there the spec 11.1 volts. So those are not true 12 volt batteries, and that's why I won't recommend any of those. Now, I do have a little bit of a rat's nest here because I just put everything together, and I got the power cable that goes into the cooler of the camera, and then I have the power cable going into the mount, and then I have a power splitter here, and then into the power supply. And then of course I have the USB cable that's supplied with the camera, which will go to my laptop, and I will control all this with SharpCap. You may have seen my video on software for EAA. If you haven't, you could look at it here. I've tried many different software applications for EAA, and hands down, I think SharpCap is the best. Everybody else tries to mimic SharpCap, but SharpCap is so far ahead of everybody else. And you can use the free version, and if you like the free version, you can pay a small amount and get the pro version and get some added features that I think are pretty nifty. Now, this isn't really my best attempt at cable management here. I haven't spent a lot of time thinking about the cable management, but I think I have plenty of cable so that when the scope rotates around, that I won't run into trouble with the power cable. And then on the azimuth slewing of the mount, I'll have to just make sure that I don't get cable wrap. It would be ideal if the power supply could be mounted up here, but I don't really see an easy way to do that. So, but this will work. It'll work reasonably well for now. And then of course this will be the USB cable to my laptop. And if I needed to go further distance, I could put an extension on this. So this is the setup I'm going to use. We're going to do some wide field EAA when it gets dark, so stay tuned for that. Since this is an Alt-Az mount, we don't have to worry about polar alignment, which makes it a lot easier, especially for beginners. But we do want to do a go-to alignment. And the Skywatcher AZ GTi has a 3-star alignment procedure. It also has a 1, 2-star, but I prefer to do the 3-star because I don't want to fiddle around trying to find deep sky objects. They're hard enough to see to begin with. Let's make it easier on ourselves by doing a 3-star alignment. So the alignment procedure varies by mount, but for this mount, the procedure is to have the telescope in the horizontal position pointing north, which I have it, with the mount itself leveled. Now, one thing I don't think I mentioned before is with this field flattener, you have to have the image plane, that's the chip inside the camera, spaced at 55 millimeters from the back of the field flattener. And 55 millimeters is usually a pretty standard spacing. So the ZWO camera has the sensor chip set back 6.7 millimeters from the front face. It has an 11 millimeter adapter, so that's 17.5. And I purchased this 37.5 millimeter spacer from Agena Astro, and I'll put a link to that down below. So that adds up to the 55 millimeter spacing that we need. The other thing is when you first start out and you don't know where the focus point is, which I didn't with this scope, it's best to do the focus during the day, and I did that today. So I point at a distant hillside, try to point it into the trees or bushes on the hillside so there's something in the field of view. Adjust the exposure. I use SharpCap to do this with a live view, so I'm getting a constantly refreshed image, and adjust the exposure way down low. I think it was probably something like 20 milliseconds or so, and then crank on the focuser in and out until you start to see some stuff come into focus. And then once I got it into a general focus, I pointed at a tree on a hill even further away, and you know, that was a lot easier to find since I'm mostly focused, and then find focused there. But of course, when it gets dark and we get started, I am going to focus it once again on the stars. I actually forgot my Bahtinov mask, which fits on the front here. And Bahtinov mask looks like this, and it gives you an X cross and a line through that X that moves back and forth until you have it focused, and then it intersects that X perfectly when you have it focused. That's what happens when you go to star parties. You forget things. I'll focus by eye as best as I can, and we'll just leave it at that. As I said before, I did the 3-star alignment in SynScan Pro, and I didn't show you that because it's kind of tedious. It helps a lot to have a unity finder. I had a red dot finder which I mounted on top of the scope Sometimes when you're looking at the image on the screen, it's hard to tell which is the alignment star, and the red dot finder seems to, at least in my case, make that a lot easier. If you want to see a similar alignment procedure, you can look at the other video that I did doing EAA with an 8-inch SCT on an Alt-Az mount. In any event, now that we're aligned, let's go. We're going to go look at some deep sky objects. And the first one I'm going to do is Andromeda M31. And we'll ask it to go to that. And then I'll bring up SharpCap. And I'm using the live view here on SharpCap so we can see what's going on live. And you can see the settings I have as starting settings for this camera. I'm not binning, I'm doing one by one, which means I'm using all of the pixels. I'm doing short exposures of 10 seconds because I have a Alt-Az mount, and I set the gain at 120 because that's one of the 100 is where the readout noise drops dramatically, and so I set it at 120. And you can see now that the alignment isn't too bad, and the mount found it, and there is the Andromeda Galaxy. So I'm going to do live stacking, but I'm also going to do dark frame subtraction because, as I said, I'm not using the cooling on this camera because I want to show you that you don't really need a cooled camera. SharpCap has a very nice routine for doing dark frame subtraction. So here's the capture dark algorithm, and you can pick how many darks you want. So I'm going to do 16 darks, and I'm going to put it in the dark library, and then I'm going to let SharpCap take those 16 darks, average them together, and create a new single dark. And it's going to use the exposure settings here of 10 seconds and 120 gain. So if you wanted to change that, you would make a new dark for that specific setup. I need to put the cover on the front of the objective. Okay, having done that, let's go ahead and I'll let this take the darks, and you can see down below here it's doing the dark frame subtraction, and it'll do this up to 16 times. It'll save the average in the library. Alright, so SharpCap has captured the 16 dark frames and averaged them, and so now got to take the cover off. Okay, so to take advantage of the dark frame subtraction, we're going to go over here to pre-processing and subtract the dark, and then here's the dark that we captured, you see, with the ASI583 and today's date. And it's gonna, and we're not using a flat. You want to get real fancy, you could do flat frames as well. So let's go into the live stacking routine. We can see now at 4 minutes and 30 seconds, you can really see the galaxy. You can play around to your heart's content. You can also see the fact that we're on an Alt-Az mount. You start to see this black line here, which means that the registration of the frames isn't perfect. So there you go. There's the Andromeda Galaxy on the wide field 60mm refractor. You can play with this however you like, what works best for your preference. I blow out the core a little too much there. Alright, let's go to another deep sky object. Alright, now another galaxy is visible, and that's M33, or the Triangulum Galaxy. So let's go take a look for that. And we're still taking images here. Alright, let's do some live stacking, see if we got something there. We got to clear out the old image and look for the new one. Alright, there's the Triangulum Galaxy. And we're a little bit off center, so I'm going to go fix that. Okay, which direction to move in? Let's come down a bit. And then let's clear this. Okay, did I go the right way or the wrong way? Okay, I think I went the right way, but not enough. Alright, so it took me a few iterations to get this thing centered. There it is. We can back off maybe in some of the... And we'll let this stack for a while. You can clearly start to see the spiral structure of the galaxy. So let's let this run for a while. I'll pause the video so we can jump ahead. Alright, here we are at 2 minutes and 40 seconds. Another thing I can show you, even though I'm not trying to do a SharpCap tutorial, is we can do color balancing here. And let's use this one, auto color balance from the star colors, and watch the screen. And you see the background becomes more grayish instead of green like it was. And we can try and bring out a little more detail. Remember, we're doing this with a 60mm refractor, not an 8-inch SCT. So it takes a little while for the image to build up. And I'll pause and we'll see how it builds up if we wait a little longer. Alright, so here's what we have at 10 minutes. You can clearly see the inner part of the galaxy. You can see a bit of the outer portions of it. Let me make some adjustments here. Again, you play with this to your heart's content. See what you like. That's too bright. Alright, so that's M33, the Triangulum Galaxy. Alright, let's move on to a nebula. Alright, let's try the helix. It's a little low in the sky, but I'm going to try for that. See, it's the Helix Nebula. Okay, you can see the nebula is up here off the screen. So let me make some adjustments to bring it down in place. Okay, as you can see, I've now centered it. And it's kind of washed, a little bit washed out. And it's not a large object, so you don't really need wide field for this, but it is a interesting object and a colorful object. Alright, and here's the eagle at 3 minutes. And let's zoom in on this. Drop this out of the way. You can see the structure in the Eagle Nebula. Not bad for 60mm wide field refractor. Alright, so I think that wraps it up. I think we've demonstrated what a wide field refractor can do in a nice dark sky environment. Before my demonstration session last night, I decided to tidy up the cables as best as I could. So I used some Velcro-like strips to fasten the excess cable here to the extension, and that way I have plenty of cable to allow the camera to rotate in any direction and not really have too much of a problem of snagging. Now, the other thing I added to the setup to make life easier is this Unity finder, which has no magnification. When you look through the glass, you see the night sky as you would just looking up at it without the finder. Now, these things typically have a red dot. This one has the capability of red or green dots, circles, or crosshairs. And that allows you to find the alignment stars and get on those alignment stars a lot easier than just crouching down and trying to sight along the optical tube axis. Now, you'd be surprised. You can see the alignment stars usually stick out because of the brighter stars in the sky. So having the red dot finder makes it easier to make sure you're on the right star. Otherwise, you'll have to redo the alignment because it won't work. In any event, that's the setup we used last night. I'll put links to this red dot finder and some other less expensive finders down below the video where it says show more. And so this is what we used last night to do our little session. So if you're thinking of a wide field refractor for EAA, I hope this video gave you some ideas. Like I said before, there are quite a few different refractors which are good options for EAA in the price range of about $450 to $600. And I'll put links to all those down below the video where it says show more. Same with the camera. You don't have to buy the 533, which is a very nice camera. You can certainly buy the 533 that's uncooled, or you can buy the 585, which is a much less expensive camera. Depends on your budget. And the mount that I borrowed from my friend Dave actually worked pretty well. It's a nice lightweight mount, and I'll put links to it below, but there's certainly lots of other mounts that you might want to consider. But I found this to be very nice, lightweight, portable. I can lift it up, carry it around, move it. It's not going to break my back, and it's also not going to break your budget. So I hope you found this video interesting and you learned something from it. If so, like the video. That makes it easier for other folks like you to find the video. And if you enjoyed what I showed you, you may want to subscribe to this channel to see more videos like this. You can also find more content with astronomy tips and equipment reviews on my website, californiaskies.com. So thank you for watching.